Hello everyone, welcome to CTC Prediction Machine Learning Project. In this project, our problem set is create a machine learning model that will help the company in determining the salary of newly hired employees using the given data. So for this, we have provided by three files. One file is provided by the employee data and two files are provided by city names and you can say college names. In college names, tier 1 colleges are these, tier 2 colleges are this, and tier 3 colleges are these. And in cities, we have metro cities and non-metro cities. So we have to create a regression task for this. Let's go back to our Jupyter notebook. So first we imported all necessary libraries like pandas, seaborn, and you can say for splitting our data into training and test set. We have train test split, grid search, see for using you can say different parameters or different models. Standard scaler for scaling our model. I'm sorry, scaling our independent variable, and these all are models for regression model like linear regression, lasso, and ridge. This is a decision tree regressor, SVR, random forest regressor, gradient boosting regressor, peg regressor, and for evaluation we have mean squared error and R2 score. Imported CSV files using df is equal to pd.read CSV, and we show first five rows using df.head, and similarly we imported college and cities data from also. Now we have to create it, now we creating a directory for a dictionary from college tables, so we can give values to the so we can place values to here. Instead of categorical values we can give numerical values. So first we defined an empty dictionary of college tier map. Let me increase its size. Here we define empty, you can say empty directory college tier map. So for I tier in enumerate tier 3 to 1. So first it will start with 1 and it will give value 1 to tier 3 and 2 to tier 2 and tier 1 to 3. For college in college tier 1 group and dot values. So we will get college college tier map, college dot strip. So in this code, we will you can say mapping our all college to the values of the you can say tier. Like if like IIT Delhi is coming in tier 1, so it will map with the value 3, and VIT Vellore is coming in tier 3 college, so it will map it with the value 1. Similarly, we do it for cities. Uh, here you can see metros is equal to cities of metro cities dot drop, and if there is any null values dot values, so it will convert into lists. Similarly for non-metro value, non-metro cities, and again we will map our city map is equal to again defined a new dictionary. So for all metro cities we will map it with value 1, and again we will update our this dictionary with you can say for city with the non-metro cities we map it with 0. So now we have mapped mapping the college into DF to their respective tiers. So we will save this into DF of college tier is equal to DF college dot map over this function college tier map, and removing a college column from data frame. So for that we will use df.drop college comma x is equal to 1 because it is column, and in place is equal to true. So this will save it in df data frame. Mapping the cities in DF to their respective types. DF, so we create a new column, city type is equal to DF of city dot and map this city map. So similarly, we remove city column from the data frame. DF dot drop city comma x is equal to 1 in place is equal to true. So now we are checking if there is any null values. For that we will do df dot is null dot sum. So there is no null values. So now we are finding the summary of the data frame. For that we will use df dot info. So we have one object column that is row. So we have to do one hot encoding for this. So for that we will use the we will save this one hot encoded into uh, role manager. You can say we defined a new column role manager. Df of role manager is equal to pt dot get dummies. Get dummies for one hot encoding, and we provided the you can say which column we have to do one hot encoding here, and draw first is equal to equal to true because we want to prevent us from multi collinearity. That's why. And as type is equal to int because if we run this code, it will be give our value into true or false. So to convert it into one or zeros, we have to do as type int. So now removing role column from the data frame. Similarly, we do tf to drop role x is equal to 1 in place is equal to true. Now we are calculating correlation heat map. So for finding correlation, we have to use just df dot core and then parenthesis. So now it will give us the correlation matrix, and we will give this correlation matrix to the you can say SNS dot heat map. So it will create a heat map like this for you can say lighter shade, it means it is highly correlated, and for darker means it is zero correlated, or you can say no correlation between two columns. So from here we can find this role manager and CTC is very high correlated. Also, CTC is more correlated with previous CTC and experience in months, also with three these columns. And in this also we can also see in this table also from so here what we will do, we find a correlation of every columns with CTC. So what we have done is df dot core for finding correlation, and then sorted then for CTC we give CTC and then absolute value, because correlation can contains negative value, that's why we absoluted all the values. So and then we sorted by decreasing order. So for decreasing order we give ascending is equal to false. So here you can see these three columns are highly correlated, which is role manager, experience, and previous CTC. Now we do some descriptive analysis for finding if there are any outliers or not. If here you can see here mean is this, and minimum and maximum value is this, which is seems nice. It is not an you can say outlier. Previous job change, minimum value is 1 and maximum is 4. Graduation marks, minimum is 35 and maximum is 85. Experience in months is minimum is 80 and maximum is 64. CTC is 53,000 and 1 lakh 1,23,000, and similarly like this. So we do not have, you can say, outlier here. Also, we plotted some hash plot for you can see the visualization. Here you can see it is creating bell. It is greatly normally distributed. It is making bell-shaped curve. And if you want to plot this line also, we have to do KD is equal to true. Here we use KD is equal to true. Here you can see. Similarly, we defined bar chart for this. Here you can see in previous job change, we have two values 1, 2, 3, and 4. which is equally distributed. Similarly, we created, you can say, histogram for all our variables, or you can say all our features. Now we splitted our data into independent and dependent variable. For that, we will define x is equal to tf dot drop. So I want to drop CTC column from df data frame where x is equal to 1, means CTC is a column. So we save this into x variable, and for dependent variable b is equal to y is equal to tf of CTC. And now we are splitting our data into training and testing set. So for that we will use train test split. We use train test split x comma y comma, our test side is 0.2, means our 80% of data will be used for training and 20% of data will be used for you can say testing data. And here random set is equal to 42. You can give any integer value here. It is just to so that if we create you can say if we again try train test split and it will generate same values, or you can say split in same manner as you can say I splitted uh, now now we are scaling our data. We defined a standard scaler here, and we put here scalar dot fit and transform. So our fit our data into our training set, and then transformed into you can say transformed that data. So if you observe this data, this data has mean is equal to 0 and standard deviation is equal to 1. And on the same basis we transform this data, but we do not fit on this data, we just transform this on this data, you can say testing data, because our scalar is already you can say trained on this training set. Then we defined our you can say algorithm and hyperparameters. So here I created a you can say a dictionary with the uh, algorithm name, and again I defined a dictionary where I have model and a defined model here, or and other value as or you can say other key as parameter, and which is empty. And in a different you can say different algorithm, inside the parameters I have case alpha and selection, and alpha has three values and selection have two values. Similarly for every you can say every model I have different hyperparameters. Then I start training my model by first I created an empty list of scores, and then created a for loop of algo name comma mp in algo dot items. So we will start a for loop on this. This will be our algo name, and this is our you can say our value or mp. So we started here grid search CV and save it in reg. We gave our model, which is this one. So for getting this, what we do MP of model. Here you can see MP of model. And for parameters, params grid, we define MP of params. Our core CV is equal to 5, means our you can say data will split into 5 parts, you can say 20 20 20 20. And for first training we will get our first part, and then for second training we will get second part. For testing data, now we defined grid search CV, and here we will give our model and our parameters grid, and CV is equal to 5, return training score is equal to 4. We fitted our model, or you can say start training our model, and then we appended our model name, best score and best parameters in this list. And then we evaluated our training results by score is equal to created a new data frame with the data scores and columns has model best score and best parameters. Here you can see from this we can find random forest is performing best in this. You can say better than all you can say all models with the parameters criterion is equal to absolute error and uh, n estimator is we can find this by evaluating this, but I know it is n estimator is equal to 500, so that's why I individually trained this. So model is equal to random forest regression. We give these hyperparameters and fitted our model on this x train scaled and y train scaled. And now we calculated our y-pred using model.pred on x-test scaled, and for calculating mean squared error we gave y true value which is y-test and y-pred value which is y underscore pred. For R2 score we give y underscore test comma y underscore pred.